Hello friends, today in alkenes chemical properties. In continuation today I will explain you addition of the halogen acids in the case of the alkenes. If we take simple example of the ethylene and the butane, ethylene reacts with HCl and form the chloroethane. In the same way, butane reacts with HBr, it forms the 2-bromobutane. These are the simple reactions. And if we say ethylene and the butylene, both are the symmetrical in nature. But what happens if we take an unsymmetrical, that is propane? How this reaction takes place? In simple way, if we say in the case of the propylene, when react with HBr, it may give you two compounds. One may be 1-bromopropane and second may be 2-bromopropane. To explain this thing, Marconi gave a rule. As per the Marconi gave rule, the negative part of the attacking reagent, here attacking reagent is HBr, hydrogen is positive and the bromine is negative. Negative part of the attacking reagent joins the carbon atom with less number of the hydrogen atom. Now in this case you see in the propylene CH3 CH2, here carbon atom number 2 has the less hydrogen atoms. So as per the Marconi rule, negative part of the attacking reagent join the carbon atom which is with less number of the hydrogen atoms. So the major product as per this law will be 2-bromopropane and the minor is 1-bromopropane. So Marconi law states that in the case of the unsymmetrical compounds, negative part of the attacking reagent joins the carbon atom with less number of the hydrogen and the hydrogen will join the carbon atom which is more in number of the hydrogens. This is in the case of the unsymmetrical multiple bonds. Now here, in the case of the ethylene, in the case of the propane, HBr reacts. Now, one thing is more important, that this propane, if reacts in the presence of the peroxides, it's a very important thing. If this unsymmetrical compound, that is the propane, reacts with HBr in the presence of the peroxide, that is benzoyl peroxide, it only forms the 1-bromopropane. This is the special case. This reaction is only with the HBr, not with chloro, iodo and fluoro. And this is known as the peroxide effect, or it is also known as the Kirsch effect. So the point is that here unsymmetrical double bond compounds when react with HBr in the presence of the benzoyl peroxide, it only forms the 1-bromopropane, that is peroxide effect, and it is also known as the Kirsch effect. Now if we sum up this reaction, propane reacts with HBr. If this reaction takes place in the presence of the peroxide, that is anti-Marconi rule, only the 1-bromopropane is formed, and if it is In the absence of the peroxide, it forms the 2-bromopropane as the major product. Now, what is mechanism behind this reaction? You see, in the case of the electrophile, in my last video I explained you carbocation. This propane reacts with HBr. HBr breaks into hydrogen ion and the bromine ion, where bromine is negative charge and hydrogen is the positive charge. Now this proton that is electrophile in nature, this electrophile nature, it will form propane in the form of the 2 carbocation or the 1 carbocation. Again listen, this hydrogen proton that is the electrophile in nature, when attacks the propane, it may form the 2 carbocations or the 1 carbocations. Here 1 carbocation is less stable and the 2 carbocation is more stable. Now this 2 carbocation then react with the bromine to form the 2 bromopropane. So this is the mechanism behind the addition of the halogen acids. So remember, Markov-Nikolai rules. This is a very important rule. As per this rule, in the case of the unsymmetrical enes, negative part of the attacking reagent joins the carbon atom with less number of the hydrogen atoms, and the hydrogen goes to the carbon atom with more hydrogen atoms. So this is the addition of the halogen acids which I explain you with mechanism. So if you like my videos, please share and subscribe. Thanks very much.